Good evening, everybody. Welcome to our STS Talk Show. I am Sab and I will be your host for tonight. So, you're joined by five Filipino inventors and they will be talking about the products that they invented. So, with that said, we can now start with the first Filipino inventor. We have Dr. Fred De Mundo.
Greetings, I am Dr. Fido Mundo. I am honored to have the opportunity to share my story and experiences with you all. I was born on November 27, 1911 in Manila, Philippines. I dedicated my life to the field of pediatric medicine. I obtained my Bachelor of Science degree majoring in chemistry from the University of the Philippines. Fueled by my passion for healing and caring for children, I pursued further studies at the University of the Philippines College of Medicine where I received my medical degree. A thirst for knowledge and desire to expand my expertise led me to the prestigious Harvard Medical School in the United States. In 1936, I became the first woman admitted to their medical program, a groundbreaking achievement at that time. It was a privilege to study alongside some of the finest medical minds and to immerse myself in the cutting edge medical advancements of the era. Equipped with my medical degree, I returned to the Philippines with the goal of making a lasting impact on the healthcare landscape for children. I became a professor at the University of the Philippines College of Medicine, where I had the opportunity to educate and mentor future generations of healthcare professionals. Additionally, I established the Institute of Maternal and Child Health, which later evolved into the Institute of Pediatrics and Child Health. These institutions aim to advance pediatric care and elevate healthcare standards for children in the Philippines. Throughout my career, I focused on creating child-friendly hospital environments, promoting preventive medicine, and advocating for the importance of nurturing and compassionate care for young patients. I firmly believe in the power of education and mentorship as they play a crucial role in shaping the future of pediatric medicine. I engage in medical research to further the understanding of various pediatric health issues, whether studying malnutrition and nutritional deficiencies, infectious diseases, or child development. My research aimed to contribute to the body of knowledge in pediatric medicine, and I actively advocated for healthcare policies that prioritize the needs of children. I recognize the importance of early interventions, access to quality healthcare, and preventive measures. Through my work, I aim to influence policy decisions to improve the overall health and well being of children in the Philippines. I serve as a consultant and advisor to international organizations, including the World Health Organization, and this provided me with opportunities to contribute my expertise and insights to global health initiatives, shaping policies and strategies for the benefit of children worldwide. And as an educator, I made a significant contributions to the field of pediatric medicine through teaching and mentoring by imparting my knowledge and experience to future healthcare professionals. I aim to inspire a new generation of compassionate and skilled pediatricians who will continue advancing the field. As a testament to my dedication and contributions, I received numerous accolades throughout my career. In 1977, I was honored to be the recipient of the prestigious Ramon Magsaysay Award for Public Service, which recognized my commitment to pediatric medicine and the welfare of children. So, in my quest to address the challenges faced by communities with limited resources, I recognize the need for an affordable and accessible alternative to traditional incubators inspired by the abundance of bamboo in the Philippines. I turned to this versatile and sustainable material as a potential solution, and it inspired me to create the bamboo incubator. So the bamboo incubator was born out of my belief that every child, regardless of their age, deserves access to life-saving equipment. It aimed to provide a controlled environment for premature and low birth weight infants, replicating the warmth and protection needed for their healthy development. And now let me explain the uses and benefits of the bamboo incubator. First and foremost, it serve as a vital tool for nurturing and safeguarding the health of premature infants. Its design incorporated natural ventilation and insulation properties of bamboo, helping to regulate temperature and humidity within the incubator, and this created an environment conducive to the delicate needs of these vulnerable infants. The bamboo incubator was carefully created to offer a safe and hygienic space for newborns, protecting them from external harm and potential infections. Its construction involved precise engineering, ensuring stability and durability while providing a cocoon-like atmosphere for the infants. Moreover, the bamboo incubator could be easily assembled and disassembled, making it portable and suitable for use in various settings, including remote areas with limited access to healthcare facilities, and this feature allowed the healthcare professionals to bring the necessary care directly to communities in need, reaching the infants who otherwise might not receive timely and specialized attention. And while the bamboo incubators served as a temporary solution, it played a critical role in bridging the gap in healthcare accessibility, particularly in resource constrained regions. It provided a lifeline for infants until they could receive the necessary care in more advanced medical facilities. And I must emphasize that the bamboo incubator was never intended to replace medical grade incubators, rather, it served as a stopgap measure, ensuring that vulnerable infants receive a level of care and protection during their early stages of life. Its implementation required appropriate medical supervision, training, and support to ensure the well-being of the infants placed within its care. And the bamboo incubator represents the spirit of innovation, resourcefulness, and compassion that guided my work as a pediatrician. It was a localized solution born out of the unique circumstances and available resources in the Philippines. Its impact may have been specific to certain regions, but it symbolizes the potential for creativity and adoption in addressing healthcare challenges. And throughout my journey, I strive to break gender barriers and inspire other women to pursue careers in medicine. My achievements serve as a reminder that gender should never limit one's capabilities or aspirations. In closing, I am humbled by the opportunities and successes I have had in the field of pediatric medicine. My life's work has been driven by a profound love for children and a commitment to improving their health and well being. It is my hope that my contributions continue to inspire future generations of healthcare professionals to serve with compassion, innovation, and dedication.
Thank you so much, Doctor. We're now opening the floor to questions once again.
So going back to my question, what made you decide to be a pediatrician, and what are the challenges that you faced and overcame throughout your career?
So, from a young age, I was drawn to the innocence, vulnerability, and boundless potential of children. Uh, fueled, their presence ignited a fire within me and a fire fueled by a deep love and desire to make a difference in their lives. However, the road to realizing my dreams was not without its challenges. One of the greatest obstacles I faced was the prevailing societal attitudes towards women in medicine. In an era when traditional gender roles were deeply entrenched, the idea of a woman pursuing a career in medicine was met with skepticism and resistance, but I refused to succumb to societal limitation and forge ahead, determined to prove that my gender did not define my capabilities. And the road implementing my vision of child-friendly hospitals was not without its obstacles. Traditional notions of hospital design often fail to prioritize the unique needs and vulnerabilities of children. I encountered resistance of children, uh, res- resisted skepticism, but I persisted through innovative ideas. Like the crib cage, I aimed to create an environment that nurtured and comforted young patients, ensuring their safety and well-being. And I believe that every child deserves the best care regardless of their circumstances or the obstacles in our path.
Next, we have Dr. Gregorio Zara.
Good morning. Good evening, everyone. My name is Gregorio Zara, and I was born on March 8th, 1902. And I died on October 15th, 1978. So today, I will present to you my life and work. So, my name is Gregorio Y. Zara, and I'm a Filipino engineer, scientist, and physicist best known for inventing the first two-way video telephone. So, what is it, you guys? It's basically what we're using today: Google Meet, Skype, and Zoom, among many others. So, my personal life. In 1934, I married Engracia Arcinas Laconico, who the year before had been named Miss Philippines. Yes. We have four children: Antonio, Pasita, Josefina, and Lourdes. So, my education. I graduated top of my class in Lipa Elementary School in 1918 and in Batangas High School in 1922. All this time, I was always at the top of my class. And in high school, when I graduated in high school, I was awarded valedictorian and I got a scholarship abroad. But the funny thing is, the the government official during this time awarded the scholarship to the second place instead. So I enrolled in UP, University of the Philippines, after. Um, a year after this, during my second year, I got the scholarship back because the other scholar who got it got sick and died abroad. After getting the scholarship, I applied at Massachusetts Institute of Technology, or MIT, which everyone knows is like a science focused university. So I graduated with a degree in Bachelor of Science in Mechanical Engineering in 1926. I also did Masters in Aeronautical Engineering, graduating summa cum laude at the University of Michigan, and a doctorate in physics at Sorbonne University in Paris, also with summa cum laude. So basically, I laid the idea of Skype and Zoom. So my video telephone invention enabled the caller and recipient to see each other while conversing. So this laid the foundation for video conferencing. This was the time in the 50s. Uh, I patented this invention in 1955. So this is the video phone. Before video calling became as commonplace today, the technology had been developed, but sparsely. Also, it was a concept more common in sci-fi or comic books during that time. So the first prototype I did, which was in 1955, I also patented that invention. It didn't catch the public eye, um, but soon AT&T got was interested in this project, and they began working on another model of a video phone called picture phone. And this was aimed at the market to the public during 6 years after I patented my design. So the company released the video phone at the 1964 New York World's Fair, but it was seen as impractical and people were uncomfortable in using this technology during that time. So it didn't fare well. It wasn't until 1990s that this concept uh, got more popular and accepted. So some context in history, 1950s, this was present during my time. Telephones were, you call this dial, you make it, I don't know, do that. And then there's fridge and ref. So this was the start of refrigerating food in freezers and refrigerators. black and white television sets, Play-Doh. These are some of just the common stuff during my time. What are my other inventions? I patented 30 devices. My other inventions range from an alcohol powered airplane engine to a solar powered water heater and stove. So in 1930, before doing all this video phone technology, I discovered the physical law of electrical kinetic resistance, known as the Zara effect. This involves the resistance to the passage of an electric current when contacts are in motion. And then I invented the Earth induction compass, which is still used by pilots. And in 1954, my airplane engine powered by alcohol had a successful test flight at the Ninoy Aquino International Airport. Okay, so this info is sponsored by thoughtco.com. So other scientific contributions. My other inventions and discoveries include improving methods of producing and harnessing solar energy, including new designs for a solar-powered water heater, stove, and battery. This was in 1960s. Inventing wooden aircraft propellers and a corresponding propeller cutting machine, 1952. I also designed a microscope with a collapsible stage. Helping design the robot Marex X10, which could walk, talk, and respond to commands. Uh, Inventing the vapor chamber used to visualize radioactive elements. So these are just some of my inventions. So in my lifetime, I amassed 30 patents. In the year of my death, I was presented the National Scientist Award, the highest honor the Philippine government gives to Filipino scientists. This was awarded to me by President Ferdinand Marcos. Uh, I also received the Presidential Diploma of Merit, the Distinguished Service Medal Award for pioneering science and technology in the country, a Presidential Gold Medal and Diploma of Honor for Science and Research for my achievements in solar energy research, aeronautics, and television. The Cultural Heritage Award for Science, Education, and Aerospace Engineering. So again, the idea of video conferencing really caught on when the digital age was beginning in the late 1990s. The video phone in the 90s first caught on as a device that easily allowed distance learning for homeschool children. There were some video conferencing done for companies. This also proved helpful for hearing impaired children. Uh, a few years later, during the 2010s or earlier than that, then came such iterations such as Skype, Zoom, FaceTime, and smartphones, and the video phone became even more popular. Today, we see innovations such as these in telecare, which is like teleconsulting, especially now and during the pandemic and the likes. Thank you, guys.
Hi, Doctor. I have a question.
Yes,
So,
yes.
were there any hindrances in creating the two-way video telephone?
Yeah, yeah, there's a lot of I think with every invention that revolutionized like the cultural happenings during that time, it will always get some backlash. People aren't comfortable with the technology. They might think it's radioactive or I don't know, something like that. But yeah, definitely. Like it wasn't 40 years, 1955. Yeah, 40 years after, and I was already dead by that time.
Up next, we have Dr. Abelardo Aguilar.
I'm a Filipino scientist from Iloilo, Philippines, and I work as a researcher at Eli Lilly and Company. It is one of the top ranked pharmaceutical companies in the US. So, anyway, my entire life I have dedicated it to serve the Filipinos, especially the poor, that I have earned the reputation of being a doctor of the poor. Because of that, it drove me to achieve probably my greatest accomplishment which is the discovery of the antibiotic erythromycin, a kind of drug that treats or prevents bacterial infections. So I work day and night observing and testing soil samples from my backyard, and so yeah, it led to that and I showed it to my district manager, and they promised me that I would be recognized for my work, but then they did not keep their promise, and I even tried to write a letter of request for my share, or to get my share of supposedly $500 million, but yeah, they rejected it. And um as soon as they knew that erythromycin is worth billions of dollars, they filed a patent and did not give me credit for it. So they forced me to resign. The money wasn't even for personal use, but more of I wanted to use that money to provide accessible health services to poor Filipinos. So yeah, they since they never kept their promise, I never received a single cent from it. So now I'm broke and I fought really hard, but yeah, they had all the rights to produce, use and sell it, and I didn't have the right since they filed a patent and my name wasn't included. So yeah, I died a poor man. That's all. Thank you.
Oh
Wow, so
no.
sad.
So sad. I have a question, Dr. Abelardo.
Yes.
Okay. What was your alma mater and what was your course in college? Since we are college
um
students.
oh, I forgot to include it. So my I finished a degree of doctorate of physics in Sorbonne University in Paris.
Wow.
Oh, yeah.
Okay. Are there any other questions from the chat? Any other questions from the chat?
Kate, uh, Dr. Abelardo, how do you feel about people not accepting, I mean, like rejecting your invention?
Actually, I felt betrayed because when I showed the samples, they promised me to like give me recognition, but in the end they didn't. So yeah, actually there was a lot of letters written like for them because they were accused of a lot of issues like racial discrimination. So I guess that's why they didn't give me credit for it because I'm a Filipino.
It's so hard. Like,
Now we can move on to the next inventor, Mr. Eduardo San Juan.
Good evening, everyone. Thanks for having me. My name is Eduardo San Juan. So uh, I'm one of the innovators, or I'm one of the engineers who helped create and design the lunar rover that were used in the Apollo project in NASA. So the background of the lunar roving vehicle, or also known as the moon buggy. So, mechanical engineer Eduardo San Juan, which is me, worked on the team that invented the lunar rover or moon buggy. So, I'm considered the primary designer of the lunar rover that the Apollo astronauts used on the moon. So, there were three lunar roving vehicles that were driven on the moon. First is what it was Apollo 15 by astronauts David Scott and Jim Irwin. And second one that I helped design was the Apollo 16 by John Young and Charles Duke. And the third one was the Apollo 17 by Gene Cernan and Harrison Schmidt. So my background or credentials, so I studied and graduated from the Mapua Institute of Technology. I studied. I also studied nuclear engineering at the University of Washington. In 1917, I received one of the 10 Outstanding Men Awards in Science and Technology. So, for the overview of the lunar rover or the moon buggy, so it is an electric vehicle designed to operate in the low gravity vacuum of the moon and to be capable of traversing the lunar surface, allowing the Apollo astronauts to extend the range of their surface extravehicular activities. It was used on the moon in the last three missions of the American Apollo program, which is the 15, 16, and 17 during 1971 and 1972. So the weight of the lunar roving vehicle had a mass of 210 kilograms. There were two side-by-side foldable seats made of tubular aluminum with nylon webbing and aluminum floor panels. The frame was 3.1 meters long with a wheelbase of 2.3 meters. The maximum height was 1.14 meters. The frame was made of aluminum alloy. It could hold a total payload of 490 kilograms, which is 1,080 pounds on the lunar surface. So for the controls, a T-shaped hand controller situated between the two seats controlled the four drive motors, two steering motors, and brakes. Moving the stick forward powered the LRV forward, left and right, turned the vehicle left or right. Pulling backwards activated the brakes. So for the cost, the original cost plus incentive fee contract was $19 million, but cost overruns led to a final cost of $38 million. So fun fact, this is the original Lunar Rover Operations Handbook issued to the Apollo 15, 16, and 17 crews.
Wow.
Yeah, so that's the original handbook that I helped make. So that's all. Thank you guys.
Thank you, Mr.
Thanks.
Eduardo. I have a question before you go.
Yeah, sure.
Did you have any inspirations for the design of the lunar rover?
So for the inspiration, so first of all, thanks for the wonderful question. Yes, of course. Um, ever since ever since I was a kid, I've always dreamed of creating something that would help change the world. Given my interests in engineering and space, NASA provided me an opportunity to achieve that goal as they were currently in the process of proposing a project called Apollo. So in this project, they are requiring designs of vehicles that can roam or explore around the moon. Thank you.
As a fellow scientist, how does it feel to have an invention that goes beyond our Earth? Like it's space, so that's very inspirational to us
Yeah.
fellow scientists.
I've been really humbled that I helped design something that is, first of all, NASA. Um, it's the product of NASA that can go to the outer space, and it's really humbling, and it's a proud moment that me growing up studying in Mapua, studying in the University of Washington, I've been blessed with the opportunity of studying with my great educational background here and in the States to help design a Land Rover vehicle for the Apollo missions.
Okay. Thank you, Mr. Eduardo. Thank you.
Thank you. Thank you, guys.
Okay. Last but not the least, we have Mr. Mark Bantugon.
Hello, good evening everyone. I'm Mark Kennedy Bantugon, and I'm a Filipino inventor of PDC. I'm a degree holder, Bachelor of Science in Aeronautical Engineering from Philippine State College of Aeronautics and I graduated last 2020. I'm a Grand Winner Ambassador of Fredo M. Yao Intellectual Property Awards 2020, Grand Champion Cardinal Innovator Cardinal Challenge 2021 Mapua Design and Innovation Competition. And I received runner-up Donggu Group's Seoul National University Global Startup Challenge 2021. Then the Pili seal is a sealing material used to avoid fuel leakages. It has also been proving effective in other areas subject to contact with aircraft fuels, lubricants, oils, water, and weathering. Pilicil, Pilicil uses waste material as the base ingredient for aviation sealant. Its quality is significantly greater than any commercial sealant, as proven by 20 different standardized tests. Moreover, this product is not only sustainable and unique but also proven safe and non-toxic to the other users' health. This product is effective for specific aircraft parts application like integral fuel tanks to prevent fuel leakages. Unlike the commercial sealants currently used, it is safe and non-toxic to the health of all users. Thank you.
I have a
Yeah.
question, Mr. Bantugon. What got you interested in aviation?
So I find it interesting that pili nuts can be used as an alternative sealant for aviation. It has been also proven effective in other area subject to contact with aircraft fuels, lubricants, oils, water, and weathering. So, thank you.
So that's all for tonight. We hope that everyone learned something from our scientists here today. Then we can
All
proceed
good.
and end this talk show. Thank you for watching and good night.
Good night.
Bye.
Thank you,
Thank
guys. Good
you.
night.
Bye.